A living forest acts as one single organism. This video might not be appealing to you, but the information it contains has something for all of us to know. Based on the studies of Suzanne Simard, a forest scientist.
The trees are speaking to each other.
Yes, that is true. Trees are talking to each other, and today's topic is about trees, how they talk, how they communicate. Can you imagine a tree talking to another tree, let's say, which is situated about 1 kilometer ahead? So we are talking about that. We are going to give some insight about how the trees are communicating. When we see trees, they are standing still. They're not moving. They don't have legs, they have roots. They're rooted in a place, but they have a different type of communication. They have a different world underground, and they are all of them are connected to each other. And that is exactly what we are going to talk about today. So we are going to talk about world's oldest social networking system, nearly 500 million years older social networking system through which all the plants and the trees of a forest are interconnected and communicating to each other. Let's saying hi, bye, I need this, I need that, can you send me some carbon, can you send me some phosphorus? So this is the kind of communication that they do. So let's have a look into how they do it. So imagine yourself walking in a forest. So what comes in your mind would be a place with a lot of big tall trees, right? But would you believe if I say tree that stands still, is connected to thousands of other trees around it? Right. Now, this is through a connection, a network connection called Wood Wide Web. It's the social networking, and I'm going to tell you in detail about it. Okay. So all we know that plants need sunlight for photosynthesis. We have learned that in school. But what about those plants? In this forest, there are so many plants grow under shades. What do they do? How do they get sunlight from? How do they get enough carbon to probably do their daily routine? The mysteries underneath our feet, where vast root system supports the towering trunks above. How they do this? Let me tell you in a bit. So these trees who are like super tall takes maximum sunlight and produce carbon, sugar. And this sugar flows down through the stem, come back to the root at the bottom. And this is where the magic happens. In this root, the tip of this root, there are a lot of fungi which are attached to it. Now the connection between the fungi and the trees are different for different fungi, but then ultimately what they do is the extra carbon that is produced by the trees are transferred to the fungi network. These fungi is connected to each other and they make a big network called hyphae, fungi hyphae. It's called mycorrhiza. These fungi can absorb nutrients and minerals from the soil more efficiently than a tree. They take up the nutrients from the soil and give it to the tree, and take up the carbon, extra produced carbon from the tree, and take it for themselves. And they also pass it on to different trees who are growing under shade. For example, if there is a tree, if there is an oak tree, which is let's say about 300 meters away from here, and that is growing under shade, and that needs a lot of carbon, and because it has very less sunlight, it cannot get carbon. So what happens is another oak tree, which is somewhere here, probably a mother tree. Mother trees are the oldest trees of the network, by the way. So these mother trees, they'll produce extra carbon, and they will send us to those trees who are under shade. This is incredible because they pass these kind of information. They are connected to each other, and they send all this carbons, minerals, and whoever needs it. But however, this is the kind of network I'm talking about. They are interconnected, that the whole forest lives as one organism. If there is somebody who is under threat, who has some problems, it releases some warning signals, and it gives alert to other species that something like this is happening. For example, for a tomato plant, if there is termite attacking it, what it does is it also sends a an impulse to other tomato plants, saying that this is something like this is happening, so guys, be alert and produce more protective enzymes. So it's like when you see a forest, you can't really say the forest is still. It's a lively place and so much happening in this forest. The forest health relies on this intricate communications and exchanges. With everything so deeply interconnected, what impacts one species is bound to impact others. Another surprising fact is that these trees can understand their offsprings. Like I said earlier, an oak tree can understand where are the other oak trees nearby in the neighborhood, and then they send more information or more carbon or more minerals that they want, then they send it to another trees. Like they kind of understand who are their relatives. Isn't that amazing? And the oldest trees have larger connections. Oldest trees are also called mother trees or hub trees, and these trees have larger connections than any other trees. One hub tree, I think, can be connected to so many other trees in that entire forest. And when deforestation happens, people cut the big tall trees, thinking, okay, this can be a very good material for reusage, let's say to make a house and this and that. But cutting a hub tree is not equal to planting another 100 trees. Hub trees are interconnected. It is protecting many other trees, or probably almost everything interconnected has an impact with these hub trees. So when you cut down the hub trees, you're actually questioning the health of a forest. So it is everyone's job to preserve our planet for generations to come, and we have to make sure that our plants are not being cut, especially those hub trees, because you cut them and plant another new trees wouldn't be equal. Like I said earlier, like Mr. David Attenborough of BBC Planet Earth says, we can still fix it. So how do you think about forest now? Differently?